Section 15 of Scientific American Supplement, number 415, December 15th, 1883. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Scientific American Supplement, number 415, December 15th, 1883, by Various. A new steamer propelled by hydraulic reaction. The oar, the helix, and the paddle wheel constitute at present the means of propulsion that are exclusively employed when one has recourse to a motive power for effecting the propulsion of a boat. The sail constitutes an entirely different mode and should not figure in our enumeration, considering the essentially variable character of the force utilized. In all these propellers, we have only an imitation, very often a rude one, of the processes which nature puts in play in fishes and mollusks, and the mode that we now wish to make known is without contradiction that which imitates these the best. Hydraulic propulsion by reaction consists, in principle, in effecting a movement of boats by sucking in water at the bow and forcing it out at the stern. This is a very old idea. Naturalists cite whole families of mollusks that move about in this way with great rapidity. It is probable that such was the origin of the first idea of this mode of operating. However this may be, as long ago as 1661, a patent was taken out in England on this principle by Toogood and Hayes. After this we find the patents of Allen, 1729, and Rumsey, 1788. In France, Daniel Bernoulli presented to the Académie des Sciences a similar project during the last century. Mr. Seidel was the first to build a vessel on this principle. This ship, which was called the Enterprise, was of 100 tons burden and was constructed at Edinburgh for marine fishery. The success of this was incomplete, but it was sufficient to show all the advantage that could be got from the idea. Another boat, the Albert, was built at Stettin after the same type and at about the same epoch, and the question was considered of placing a reaction propeller upon the Great Eastern. About 1860, the question was taken up again by the house of Coquerel de Serang, which built the Serang No. 2, that did service as an excursion boat between Liege and Serang. The propeller of this consisted of a strong centrifugal pump with vertical axis actuated by a low-pressure engine. This pump sucked water into a perforated channel at the bottom of the boat and forced it through a spiral pipe to the propelling tubes. These latter consisted of two elbowed pipes issuing from the sides of the vessel and capable of pivoting in the exhaust ports in such a way as to each turn its mouth downward at will, backward or forward. The water expelled by the elbowed pipes reacted through pressure as in the hydraulic tourniquet of cabinets of physics, and effected the propulsion of the vessel. Upon turning the two mouths of the propelling tubes backward, the boat was thrust forward, and, when they were turned toward the front, She was thrust backward. When one was turned toward the front and the other toward the stern, the boat swung around. Finally, when the two mouths were placed vertically, the boat remained immovable. All the evolutions were easy, even without the help of the rudder, and the ways in which the propelling tubes could be placed were capable of being varied ad infinitum by a system of levers. The Serang No. 2 had an engine of a nominal power of 40 horses and took on an average 30 minutes to make the trip backward and forward of 85 kilometers with 4 stoppages. The success obtained was perfect, and the running was most satisfactory. It was remarked only that from the standpoint of effective duty, it would have been desirable to reduce the velocity of the water at its exit from the propellers. Mr. Poyon attributes the small effective performance to the system employed for putting the water in motion. At time of Mr. Serang's experiments only centrifugal force pumps were known, and the theoretic effective duty of these, whatever be the peculiar system of construction, cannot exceed 66%, and in practice falls to 40 or 50% in the majority of cases. It is probable, then, that in making use of those new rotary pumps, where effective duty reaches and often exceeds 80%, we might obtain much better results, and it is this that justifies the new researches that have been undertaken by Messrs. Maginot and Pinette, whose first experiments we are about to make known. In order to have it understood what interest attaches to these researches, let us state the principal advantages that this mode of propulsion will have over the helix and paddle wheel. The width of sidewheel boats will be reduced by from 20 to 30%, and the draft of water will be diminished in screw steamers to that of the hull itself. The maneuver in which the power of the engine might be directly employed will be simplified. A machine will be had of a sensibly constant speed and without change in its running. The production of waves capable of injuring the banks of canals will be avoided. The propeller will be capable of being utilized as a bilge pump. All vibration will be suppressed. The boat will be able to run at any speed under good conditions, while the helix works well only when the speed of the vessel corresponds to its pitch. It will be possible to put the propelling apparatus under water, and finally, it will be possible to run the pump directly by the shaft of the high-speed engine, without intermediate gearing, which is something that would prove a very great advantage in the case of electric pleasure boats actuated by piles and accumulators and dynamo-electric machines. We now arrive at Messrs. Maginot and Pinette's system, the description of which will be greatly facilitated by the diagram that accompanies this article. The inventors have employed a boat 14 meters in length by 1.8 meters in width, and 65 centimeters draft behind and 32 in front. The section of the midship beam is 70 square decimeters, and that of the exhaust port is 4. At a speed of 2.2 meters per second, the tractive stress K is from 10 to 11 kilograms. At a speed of 13.5 kilometers per hour, or 3.75 meters per second, the engine develops a power of 12 horses. The piston is 19 centimeters in diameter and has a stroke of 15 centimeters. The shaft in common of the pump and engine makes 410 revolutions per minute. It will be seen from the figure that suction occurs at the lower part of the hull at A, and that the water is forced out at B to impel the vessel forward. C and C' are the tubes for putting the vessel about, and D the tubes for causing her to run backward. Owing to the tubes C, the rudder has but small dimensions and is only used for directing the boat. The vessel may be turned about in situ by opening one of the receiving tubes according to the side toward which it is desired to turn. This boat is as yet only in an experimental state, and the first trials of her that have recently been made upon the Saône have shown the necessity of certain modifications that the inventors are now at work upon. La Nature. End of section 15.